So welcome to my presentation today. In the last class, we have discussed about few of the websites that forecast weathers. Uh, we actually analyze three different websites. One is from UK Met Office, another one is from NOAA, and from Bangladesh Meteorological Department. So we understood that how different ways the weather can be forecasted. Sorry. Today we are going to discuss about few informations, two topics. One topics is what are the things we need for weather forecasting, what are the tools, what are the knowledges we need, and then we're gonna discuss about few things of the satellites so that we can understand how satellites can be used in our meteorological aspects. That means weather forecasting. So a successful weather forecasting requires few of the knowledges, different sets of knowledges. That also needs some tools and techniques and methods also. But first of all, we need a good concepts. We need a good understanding. The person who is going to forecast the weather, that person should be very well understood about the subjects, about their forecasting matters. That person should be well trained. That means he or she should know all the aspects of his or her particular techniques and methods. And that person should be engaged in forecasting things. That person should not engage any other matters, because the forecasting itself a very tedious and very what I can say, very experienced and fully concentrated works, so that any person who is involved in there, that person should be engaged fully there, his or her works in this type of things, so that that person can understand. It is not a what I can say, it is not a matter that one day I go there and suddenly I produce some forecasting and next day I do something else. It's not like that. It's a very continuous process, and that is based on fully on your skill and your practice. So that's why it said that it should be engaged fully. Then that person should have very good knowledge and experience about the meteorological phenomena, different sets of meteorological phenomena, not only the some of the attributes, but also different sets of knowledges. So that person should have basic knowledges, and then that should have very good knowledge on and experience on that particular forecasting system. And then meteorological weather forecasting also need a good understanding of the local weather, because particularly we are interested about a local system. Although we have also seen in the weather forecasting about the regional phenomena or sometimes in a continental basis, but mostly we are interested about our local weather. So about the local weather, that person needs very good understanding about the local phenomena. A good example is we are, for example, a person may be going to discuss about the weather phenomena of Chittagong, and that person is wanted to forecast the weather about Chittagong, but he or she is not very um, informed about Chittagong. Maybe that person is from another part of the world, and then some of the knowledges that shows that there will be a precipitation on Chittagong within coming 2 or 3 hours later. And then that person thought that it could be, the all the other information shows it could be a snow, but actually maybe on one or two different aspects that is absent in there in the information, and that person may mislead that there will be a snow as a precipitation. But if that person have in his or her ability or experience that Chittagong or this type of area of this region never experienced about snow, they are in a tropical region, and they shows mostly the precipitation, sometimes hail. If all the information is in his or her hand, then that person may recheck their system, and then found that this precipitation is hail rather than a snow, or it could be only a freezing rain rather than a snow. So local weather is very much important. Another thing is climatic knowledge. uh, what do you mean by climate? We know that climate is the average of the weather pattern, or weather attributes of the weather. So depending on the knowledge of the climate, we can also set target about, we can also have our knowledge improved about the local conditions and a particular types of weather phenomena that can be possible in a particular season in an area. We can understood that. uh, as I said before, forecasting is always dependent on models, so we need good understanding about the models. We need to one thing is practice. That means we can use the model very well, fine. You have the data, you input, make some input in the model, and then you get some output. That is one thing. Another thing is you need to know the logic inside the model. Why you need that? Because all the models cannot be used for everywhere. Some models is dependent on different sets of data. From one data set if absent, then it can change its nature. For example, we need we need from a particular model, we need 50 different kinds of data, and then some data are missing in there. Another model that needs 25 or 20 different types of data sets, attributes, and you have all the information in your hand. So your that information with the second one, you get good amount of the dependable results, rather than you can depend on the first one where you have missed some data sets. So you should know about your model strength, you should know about your that weakness. And sometimes some model are biased, so you need to understand how you assess the biasness. For example, some model is very much suitable for cyclonic pattern analysis. Maybe they are not suitable for snow measurement or some other things. So which model you wanted to use, you should know their advantages and disadvantages. And finally, you also need some human cognition and interpretation. That means how your weather forecasting can be interpreted. Even if you have all things in your hand, your input output is in there, but how you can interpret that, that is also very important, because sometimes the interpretation itself can give you a different sets of idea, because interpretation also depends on your experience and your knowledge about the particular locations and particular types of incidents. So as a whole, we can say that weather forecasting needs a very skillful and reliable understanding of the model, and also we need to know the tools, and that means sort of different types of tools we need for the weather forecasting, and other aids also. Here NWP means numerical weather prediction. So we need some numerical prediction models. Numerical means number. So we need some numbers. What are the numbers? The numbers are different types of climatic attributes: temperature, precipitation, humidity, sunshine, and many others. So all these are numbers. So those numbers can play a significant role in particular different set, because you know also these numbers are nothing. They are different sets of attributes, and these attributes also dependent on their units. So models, they should analyze what is the, for example, what is the humidity percentage that can give you a rain. So humidity percent may don't only depend on this humidity percentage, they may also depend on the altitude, they may also dependent on the temperature, they may also dependent on the other things. So how they can combine together, what is the logic inside? So all things make a forecasting very reliable. Now here is the figure that shows the weather forecasting process. In the top of the top of here, you can see there are some knowledges you need. You need a meteorological knowledge and experience. You need some geographical knowledge, that means local area. Similarly, you need the climatic condition of that particular area so that you can understand where it is and how it behaves in different seasons. You need some local knowledge, that means what is the condition of local system. And also user needs desirable forecast attributes, that means to verify that you can also have some other knowledges to understand it. With these knowledges, when you started with, you need in the circle, you see there are two things. One is your tools and techniques in the right hand. Another thing is your skill as a human. So your skills, integration and interpretation, when come to forecasting system tools, then they're gonna work. So how you can work? You have this knowledge in the first hand, the four different color boxes. You have these knowledges, and then you need some couple of things where you can analyze. So before analyze, in your hand you need some information, the output, how the output is coming. First of all, you need some numerical model output, as I said before, numerical output. So you have in your hand that what are the different sets of climatic weather attributes that you can get from different sets of model. When you have that, you should have assessed that accuracy of that particular model so that you can depend on that. If your accuracy rate is fine, more than 90%, 95%, then you can depend on that. If your accuracy is not correct, you cannot use that. And how can you do that? You can do some statistical checks. There are some models of statistics. They can show you about their correctness assessment. What is the accuracy rate of that particular model? In doing so, you can also assess the post-assess model output. That means after your result, you can again reassess that so that you can understand the accuracy rate. Or sometimes it can also show you if it is biased with something. For example, they are very much biased about some low pressure system, so every other attributes is not in there, so they are not going to work. So you have to well understood about that, and then you can take these things for your integration. In the lower side, you can see what are the different things you can get. So this is your model output, which will give you the idea about a particular sets of data sets. And now you have very reliable data sets from your observations. Observation means what we can get directly from different types of sources. It could be from any instruments, it could be from your open eyes, everything. So observation, meteorological observations, that should also go to these processes. And with going to that, we also see other type of forecast and recent forecast, so that we can see the meteorological observations are good enough. So now the question is, if my meteorological observation is real-time data, why I need other sets of forecast? I need that because sometimes it can be also wrong, because maybe it say it's 17 degrees centigrade, but actually in your hand it is written as minus 17 degree. Sometimes it can be happened. Or maybe the temperature is in daytime and it is in the night time, or something else. So you need to correlate with that. How can you do that? If you see other forecast, then you can check that with your hand. So you can just take a good look so that you can understand, well, my information is relatively very near to the others one, so that we can depend on that. Everyone is looking for others type of observations, and then your observations is fine. and then you can again see your accuracy rate of your observation if you need, and that time you assess your accuracy and biasness, and finally you get this information in your hand which you can integrate, and you can use some tools and techniques so that you can get a product. So this is your forecast product, what you can use to show to the audience. And yes, in the last class we have discussed about how we can different ways we can show our different results. And again, these products can again be used for a recent forecast. So anything which has been produced that can be used for a recent forecast. And recent forecast is again used for the next one. So this is the whole process how we can use weather forecasting system. Now, weather forecasting techniques and tools, they analyzes the forecasting system. But what a forecast deals with, forecasting system deals with three distinctive things. One is past, one is present, another is future. So what has happened already, that is one of our question, and that is fully reliable because we got the information from a from already that is recorded. So after that we can analyze why it has happened, what was the behind causes about this incident. So any cyclone that has happened, so we can analyze now how it has happened. In the present context, we see some incident now which is going on. Then we can also found this from observations, or maybe we can take this information from some models or instruments. And then again we can ask the question, why is it happening now? And then these two things is very easy, and they can be based on real-time data set which can be found from past data sets. And now you can what is your challenge, that you wanted to know about the future conditions, what will gonna happen. Then you have to depend on particular types of modeling. And what is the basis of that? Two things your basis. One is your data set that is coming from observation of past things. Another one is your skill and your technique, your knowledge, everything to you, which is shown here in here. So the tools and techniques you have and the knowledge you have, so both together you can produce a good one. So that will answer your question, what will happen. Okay, but it is very difficult to know why will it happen, because it is not happened yet. But if it will happen, then why it will happen, you should have also answer it, because this is your logic. Without this, what will happen, you cannot get the real answer. So you have to conclude that why it will happen, why will it happen. So this is the critical questions a weather forecaster is in their mind. And now we will see the scale of the weather forecasting system. Uh, from the very first, we need to say that if a weather forecast, weather or climate forecast, anything, if any forecast we wanted to know about a bigger area, for example, if we wanted to know the different conditions of the weather phenomena of the whole world, it is much more wider place and much more easier to say the average. The more you concentrate in a particular location, you have to go very inside, and that is also influenced by the other types of weather phenomena from other locations. So that is tough to explain and to predict. So that's why it has very challenging when your location is very small. So from the planetary scale, we can know about the planetary basis knowledge about the forecasting system. If we go for next level, it is synoptic scale, a more concise synoptic. We also discuss about couple of thousand kilometers, and then meso scale give you idea about couple of lower level area, couple of 100 kilometers. and then local scale is very specific in a particular area. Now the question is, which one is more easier to understand? Planetary scale is very easier to understand because the average condition of the planetary basis, when you say, you can understand what will be the condition in a particular locations. For example, the tropics or polar region or Arctic region. We know Arctic is very cold, polar is very hot, we know that. And we know that humidity is in here, there is less humidity in there. We know that this is the average condition, this is not a local condition. So this is very specific, and you can gauge it, you can get the information very well, and then you can explain it. But if you think about a local scale, how can you explain it? It is very tough, because even you know everything, first of all, that in a local scale, you don't have much more weather station in there. Maybe you have to depend one or two stations, or maybe three stations, fine. And then you get a couple of information. But think about, this is the information which is in your places. So for example, we wanted to know about the information about the Chittagong University. We wanted to know the forecast of Chittagong University. And then maybe there is a weather station in here, and I wanted to depend on that. And we have explained everything based on that information. But maybe we don't have many informations by its surroundings, which can influence this weather. A good example is, just think about some air masses which has been originated from the Bay of Bengal, and that is full of humidity at present context maybe, and within 2 hours that will come to Chittagong University. But that information is not in my hand, because I am very much interested about the local scale, and I dependent only the information in my hand. That means the local weather station. So maybe the answer will be very wrong. So that's why planetary scale, synoptic scale is much more easier to understand, and they have much more what I can say, dependable results rather than the local scale. Yes, obviously there are some good models. They can also depend. They can also include some information from the meso scales and synoptic scales, so that the local scale can be influenced from them, and then they can analyze that. That's fine. But if you don't include those, then local scale is relatively tougher. So what we should do, we should answer the question about past, present, and future. We should also avoid the mesomyopia, means confusion of the scales from a particular area, particular scale, because when we wanted to do that, when we wanted to avoid that this confusion, we should also understand the greater area before, because if you know that information, then when you analyze the local one, you can make a relation. But if you don't know the others, then directly go to the local scale, maybe there is a chance of um, misinterpretation. So how can we do that? We can go for a larger scale first, then we need a very high resolution models for the local system, because we divided normally whole the area in couple of grids. Whole the world has been divided couple of grids. Now most of the information is coming from the satellites, and some of them from radars, and some of the local stations. So satellites, which comprises most of the information from the outside of the world, that information is based on the grid. They can give you the information about each of the grid, and maybe the local scale maybe fall in two grids. So one grid information with other grid information, when come together, they give you a different sets of idea, these different sets of results. And again, that is also mixed up with, and also influenced by the other grids. So for example, this whole picture, this whole slide, if you divide it in 12 different grids, so one grid is in here, one grid is in here, one grid is in here, like this. So each of the grid, if you have this information, now somewhere from 3 or 4 grids your location is, or maybe in one grid your location is. But it is very easy to understand, very easy to make connection that other grid also influence those environments. Okay, so that's why only a single grid information when you wanted to analyze, it is not correct actually. It will make us misinterpretation. So that's why we need a high resolution models, evaluate the confidence of the larger scale forecast, and before the progressing of the smaller scales. A smaller scales is in here, so we need to very careful about that. And obviously, to understand the local scale and interpret, you need very good local skills, because without that local information you cannot go further. Okay. And also we need to aware about the outlier of the atmospheric boundary, because local scale doesn't actually mean that the administrative boundaries. No, local scale means, as I said, as they said, atmospheric outlier means in the atmosphere, this type of air mass and this front is working on, and how long it extends and where it ends, where it has been started with, and each of the stage of your local phenomena, how it has been distributed vertically. Everything should have to be properly understood. So then you can go for a local interpretation. Okay. Now we are going to see some tools that should be that can be used in weather forecasting. These tools, first of all, we need some knowledge of the climate. This is the first techniques, or we can say some concept we need. Secondly, these tools also include the persistence. That means very stabilized conditions should be need for your understanding. Then you need some observations, which is the main basis of your modeling. Observation can be coming from many sources, as I said before. It can be from your eyes, it can be in situ surface and upper air, it could be coming from wind profiler or RASS. RASS means radio acoustic sounding system. It can be also from different satellites, it can be coming from radar or weather cameras. So different sets of sources give you the observations. Now the question is, what type of observations you need. So depending on your weather forecasting, you can set up your observation pattern. Do you need temperature data? Do you need humidity data? Do you need other sets of data? So different data sets is coming from different sets of sources. Among all of them, maybe satellite is one of the most useful one, because maximum amount of the information coming from satellites. A few other cases we can use some other things. We should also have some local instruments, for example, wind profiler, or this one, uh, or maybe from weather station we can get someone. But but that can give you a particular location, and time to time, every time up to date data is much more scarce throughout the world. So that's why forecasting depends on much more on the automatic system, which is coming from satellite or other things, radar stations, radar beams. Weather forecasting also needs, after these observations, they can go for manual analysis. How to do that? Manual analysis means you set up that logics by your own brain and by your hand. Maybe you have some graph, where you can set up different information to find out the solutions. For example, you have information in your hand about the pressure in a particular locations. You have uh, you have good amount of the information about the wind speed, wind direction, humidity, cloud, and this type of information. And all this information you put up in a map so that you can understand what would be the answer. So there are some charts that shows you that particular idea. Okay. And then from that particular idea, you can get the results. So this is your manual analysis. But manual analysis, when you do that, you need to also include all sets of logics in here so that you can get a good result. Okay, if you miss it, then it might be a little bit tough. So you have to have a checklist so that you include all of them, and then you put it, and you can get a good result. uh, with After that, without manual analysis, if you can do that, fine. And then normally we do use some models. Normally we do use numerical weather prediction models. There are many models throughout the world, but those models actually, what they do analysis the numerical numbers, and they include also some global and mesoscale models inside them. And after that, they ensembles the forecast system. Ensembles means to combine together into the forecast system. So one is model output that give you the data sets. Another is your forecast system, that means what is going to be happen. So one is your basic idea. If you have these things in your hand, that will happen. This is your logic, that is model output. Another thing is what will gonna happen in future with these sets of data. Your skill, your knowledge, and your everything, depending on your understanding, you can go for a comments that will gonna happen. And that is dependent on your experience, your idea, and your output also. And each of them, you should go for a model output statistics. That means your data output, on the basis of those results, you can check it out, how much accurate is that, and what is the relationship with those output with your input, so that you can more confident about your results, and you can explain it very nicely. And when you decide something, that this is your final comments on the weather, which is coming within couple of hours or days or weeks, then your visualization system is in your hand. How you wanted to visualize this? Should you show it in your graphs? Should you show it in your writings or any other pattern? And what is the interval uh, of your forecasting system? Is it 12 hours, 6 hours, 3 hours, or 1 hour? So depending on each of them, you can set up your targets, and then you can analyze it. Model output statistics, which we use normally to find out the accuracy. Then we do that type of statistics. If you do more and more on that, then there are some advantages and there are some disadvantages on that equations. If you have that, if you use that, then we can say this is a very easy going instrument tools. And then it is cheap and easy to find the solutions. You can correct your system model biasness very easily. You can mix up numerical prediction and statistics together in here, and they can well generate weather patterns in that type of statistical model. But there are some disadvantages about this type of model output. First of all, they cannot handle model changes. If something uh, happened within the unusual events, then it is very tough to include that things in that particular model, because they are very straightforward. They depends on what you give and what will be your output. So any other logics they will not consider, particularly the unusual events. Secondly, if you are dependent much more again and again about these model output statistics, then the forecasters skill will gonna diminish. That means their skill is not anymore in actions, and then they are fully dependent on numbers. Their experience will not gonna work, and that will also mislead sometimes your interpretation. This might also be happened. So before I going to satellite, the next topic, may I ask you if you have any question regarding forecasting tools, techniques, and concepts? If anyone have any question, you can ask me. Can you hear me?
Yes, sir.
Okay, so I think there is no question. Yeah. If you can't ask also, you can also write down in the chat so that I can see and answer you. Anyway, so next thing is satellite. Satellite is now widely used for many purposes. Uh, on such purposes for meteorological aspects. Although you have another course in your fourth semester, remote sensing, aerial photogrammetry, remote sensing, and GIS. In that course, you will know it very bit elaborately. But here I wanted to describe a little bit so that you can understand how satellite can be used in meteorological aspects. Before we start the information about the satellite uses, just very quick review about the history of the satellites. So when satellite was not used, then that time the scientists, they have used different types of balloons and kite flights so that they can observe the atmosphere. So they wanted to know the pressure, they wanted to know the temperature. They set up that things in the balloon and then we got it. Even nowadays also we also use some balloons, as I showed before in other classes. So first, in 1929, a rocket has been launched. Rocket means a payload rocket. That means not very good high strength rocket. It's a very simple one. They just throw it with a camera and a thermometer and a barometer so that they can understand the temperature. Some pictures they can take and barometer. That was launched by Robert Goddard. And then after the second world war happened, and within this period nothing much was developed. And then Sputnik 1 was launched by the Soviet Union in 1957, although this satellite is nothing related with any meteorological aspect. They sent it, actually that time the whole world has been divided into two powers. One is Soviet Union bloc, one is USA bloc. So Soviet Union wanted to show their first attempt that they can set up satellite in the axis, in the orbit. So they set it out launched it in 1957. And with the very quick time in 1960s, USA launched Tyros. TIROS means television infrared observational satellites. It means a particular sets of band that can be transmit through these satellites. And after 1960s, within 5 years, this type of satellites, 10 different satellites has been launched by USA. Now, question is, within 5 years, why 10 satellites? Yeah, 10 satellites because within that time period, anything has been changed, anything has been improved. They can be uh, someone asked, uh, these satellites is still working? Yes, some of them are working. Some of them are working. Some of them are not working. Basically, there is every satellite has a lifespan period, so they can be after that they cannot be used anymore. But these type of satellites, which I mentioned in here, nowadays it can be improved much more so that they are not anymore widely used by the providers. Yes, maybe they can round the orbit according to their fuel, according to everything. But some of them are still in there, which cannot be used widely. So sometimes we also say atmosphere nowadays, we can say after few years, somewhere in the atmosphere would be a rubbish ground. That means which cannot be used but remain in there, because if you wanted to take it down, that needs much more expenses, which is not very beneficial for the organizations or countries. So that's why some of them are still in there, but most of them are not used anymore because the satellite quality has been improved a lot during this course of time. Sorry. And after that, Environmental Science Service Administration, ESSA, from 1966 to 69, they also set nine different satellites. And first, this is the attempt where the environmental phenomena had been recognized. So at the very first time, they showed their powers through the satellites, and they took many informations for spying for military purposes. But after that, the information has been used for different purposes, for land use, for other types of use, for meteorological phenomena. So different purposes they have been set up. So now question is why the same satellite cannot use for different other uses? Because satellites is dependent on to take the information on the basis of their sensors, on the basis of their strength, on the basis of their orbiting time, sorry, many things, and the axis also. So first this type of satellite on is Nimbus, which has been included many different things. For example, they included in their system different sets of Vidicon camera. They allowed infrared imageries, microwave radiometer, infrared sounders, and they also have three-axis stabilization system in there, so that they can analyze the depthness of different phenomena such as clouds and many things. So this is one of the greatest, one of the important innovation in meteorological satellite development. And then after, as you asked me, you see in Tyros 1960 they set up launched 10 different Tyros, and then Tyros N series, they include many different other things in their system. They includes moisture, temperature instrument to take this information. They include cloud parameters in their system, and sufficiently in every aspects. In 1966, geostationary satellite has been stabilized or launched in the to the atmosphere, so that they can provide images in a very small time period frequency. For example, in 20 minutes they give on images, so now you can have a greater observation for all the time in your locations. But there are some disadvantages also that type of satellites. I will explain later. And for all this type of information which has been set for these satellites, most of them are coming from USA. But later, many other organizations such as Japan, other countries such as Japan, or European countries like Germany, France, and different others, they sent many satellites to find out different purposes, for example communication, or meteorological phenomena, or environmental aspect to analyze. And most of them are coming from USA, as I said, and that is coming from a organization named NOAA, National Oceanic and Atmospheric Administration. So depending on the purposes, satellites can be different types. Meteorological satellites give you the idea about the phenomena of the weather components, temperature, sunshine, and many others. Radio and TV broadcast satellites, they give you about the communication satellites, such as satellite of Bangladesh. So Bangabandhu satellites is one of them, which can transmit only the communication bands. They don't have any information about other type of bands. Basically what the satellites do, satellites can take up the different types of rays, or we can say radiation. So radiation can be divided on the basis of the wavelength, and some of the wavelength we can see, which we call visible light, and the others we cannot see, but that also light. For example, some lights are infrared, some lights are many other different types, and those lights cannot be seen by open eyes, but can be take up by the instruments. So though each of the satellites do something else. For example, military satellites, they are used, their satellites to find out the information which is hiding from somewhere. Okay. Some of the satellites are used only for the navigation purposes. For example, we are using nowadays very much habituated with GPS. GPS to find out an unknown location, or we can also use it for to understand the road condition, traffic jam, everything in there. So these type of satellites give you idea about the navigation. So depending on the purposes, you can set up your satellites into the orbit. Before I going to explain about the GPS, just a quick understanding about where we should set up the satellite. This is our Earth. We know that everything outside the Earth or in the top of the Earth that is attracted by the Earth, which we termed as gravitational acceleration. And gravitational acceleration that always tends to take the things inside. So it is a force of attraction which wanted to come inside. On the other hand, uh, when something is moving outside any center, that things wanted to go out if you just lose it. For example, this is a satellite, so that orbit is like that, although the orbit is not like that, but just to make you understand, so they are moving. Okay, so this movement is how the question is how fast that should move, what is the speed of the satellite in a particular location. So that depends on the attraction force. So how what is the attraction force? That means mass of your satellite is attracted by the gravitational force that give you a attraction force, and that tends to take it down. On the other hand, you wanted to stay in the orbit, so that you wanted to move because your movement take you outside the circle. So when the two force come into same positions, that means incoming and outgoing, if their amount is same, then your position will be in a very constant way. So you can move in a way so that your position will not be changed in your orbit. So the amount of the attraction should be equal to the amount of the force that is going to outside, centrifugal force and then other force to take it inside. So to go outside. So both of them uh, should be same, amount should be same. Then you set up your target. So the more of your position outside the world, then your movement will be slower. But if your movement is very sorry, not very constant is always, but if your position is very near to the earth surface, somewhere here, so your movement should be more faster, because in that case your radius will be lower, and your radius will be lower means you have to move fast because your attraction force increases, so your outgoing forces should be increases. So that's why your force should be much more. So with this observation, we set up our satellites in different layers. Basically, four different layers we have set up our satellite orbits. One is the bigger one, uh, geostationary earth orbit, this red color. It is located more than 36,000 kilometers away from the earth, and now you can understand it needs a constant movement throughout the earth orbit, because they wanted to see from a long distance, and this long distance also correspond that their attraction force is also weak. Okay, and then the bigger black color one, which we called MEO, means medium earth orbit, and it is from 6,000 to 20,000. This is the radius from the earth surface, earth center. And they can also move very little bit quickly. And then we have the smaller one, which we called as LEO, low earth orbit satellite, which is only 500 to 500 kilometer away. Sometimes we can also see those satellites sometimes from the open eyes, we can see sometimes. And then there is elliptical shape one, the green color. This is highly elliptical orbit. You can see somewhere it is very near, somewhere it is very little bit far away. So depending on your purpose, you can set up any satellites in any orbit, but your movement speed of your satellites depend on your distance from the Earth surface and your mass of your satellite, and that means weight of your satellite. So there are many orbits, but depending on the orbital path, we can set up two different types of satellite. One is geostationary, another is polar orbit satellite. Polar orbit satellites, as it is very close to the earth surface, so they move very fast, so they can observe the same area within every 12 hours. So their movement uh, should be always movable. They should pass the earth surface very quickly, each of the locations, uh, because their altitude is very near to earth surface. On the other hand, geostationary satellite is far away from the earth surface. They can be remain very constant, and they can move with the movement of the earth rotation, so that they are very still. They don't change their positions, and they can cover a wide range of area. For example, from here to here, a wide range of area they can see, particularly half of the world they can see if they want. So with those, not half, maybe a little bit less than half, but they can see a good portion of the earth surface. But the problem is, as the distance is very higher, very long enough, so from this distance the images are sometimes not very clear. That means the resolution is low in that time. On the other hand, polar orbit are very close together, so their resolution is very fine. But the problem is they cannot set up in a positions all the time, because their movement should be fast, because they are very close to the Earth surface. Their attraction force is much more greater. So that's the types of the satellites depending on your purpose. And another thing is these geostationary satellites should be on the plane of the equatorial plane. That means 0 degree inclination. They are on that plane, although that is 36,000 kilometer away, but on the plane, so that they can see the maximum portion. If your position in the plane, that means the wider portion of your earth, of the earth, so that they can see the maximum amount of the area. If that is in the top of the polar region, then it might be very difficult to see the whole world, because from the polar region you can see a smaller portion of the earth surface, because earth is not fully a circle things. They are like orange shaped, so your position should be much more wider in the equatorial plane. Now the GPS, a good example of the uses of GPS in our navigation system, and this is very important because most of the cases we use GPS for many purposes. GPS can give you, basically they give you two information. One is latitude, another is longitude. So you can find your positions, and depending on that, your apps, your software can give you other type of services. So GPS is a normally we do use Navistar, Navstar. They are a combination of network of the GPS of 24 orbiting satellites. From them, always they are looking for you, and they remain in the six different orbital paths and four different orbital plane. Orbital paths means different, not in the same positions. They are moving after every couple of hours in different paths. And orbital plane means if they are in the equatorial plane or polar region or any other region. So four different satellites in four different not four satellites, four different orbital path plane. They remain 24 orbital satellites, and their rotation period is 12 hours, as they are polar orbit satellite. And from this GPS satellite we can get the information about the latitude and longitudes together, when at least three satellites come together, because they are tracking you from the beam from your GPS. They wanted to track your system. Even your mobile sometimes have the capacity of the GPS, so they can get the information from this beam or this ray to just identify you. And then altogether they found three different axes, and from three axes they can set up two different points, for example longitude and latitudes, and they give you your position. Application of GPS, I'm not going elaborately that things, because you know that in your own already you have this knowledge in your brain, and you can also get the information in the next semester. But very quickly, they can be used for everywhere. Everywhere you can use it for transmission, transportation, for construction, for recreation, survey, or maybe any type of uses. All over you can use GPS. This is all about. If I wanted to explain it next time, but application of GPS can be anywhere. So similarly, the satellite images can also be used for different purposes. Just see these images. You can see different features. Can you say what are these things? Can you see that and understand it? What are these things?
Sir, car parking.
Car parking. So the image is very clear and you can understand what is going on in here. Okay. And you can see the roads, you can also measure the width of the road. You can also see there are some trees in the middle of the trees. You can say this is a large van, this is a minibus, this is a car. You can also segregate each of them because the picture is very clear. See this one. This is after Hurricane Katrina. So you can understand this is a site that has been demolished by this site, and you can see there are some dark green color in here, some vegetation in here. You can understand that this is an area which has been constructed something, but you cannot understand what is this. Maybe these are some houses, or these are some other business pattern things, or maybe there are some vehicles in here that has been demolished. So the picture is not too much clear, but still it is okay, you can understand something. So what are the pictures that we need for analysis? What should be the quality, and why it is different than one another? So we need some characteristics to find out a good pictures. So first of all, the satellite sensor, that means camera sensor. Different types of sensors can give you different sets of data sets. On satellites camera, that can give you the visible light, so that whatever you can see, you can just throw it and you can see it. Other type of satellites that can give you the idea, or they can throw you the infrared, or they can also capture the information about the thermal in a thermal wavelength. So each of these sensors, they can have their own system to capture it. Sometimes they can be multispectral. That means different types of rays they can capture. So your sensor, how qualityful is your sensor, depending on that, you can get the information. For example, your sensor is can capture only the visible light, then you will not be allowed from that images. You cannot analyze what is the temperature of that location. But if your sensor is a thermal sensor, then you can get the images, and then from that images you can analyze what would be the temperature of that particular location. Maybe the red color, yellow color, green color, blue color, they have each of the meaning for each of the wavelength of the thermal radiation, and you can understand the temperature of the ground. Or maybe there is a grading system. You see this is dark red, it is light red. That means each of them can give you idea about the changes of the temperature in different directions. So all information is in here, depending on your sensor types. This is one thing. Another thing is resolution. If your resolution is very good, then you can understand the things, each of the things very clearly. For example, if your resolution is 1 meter by 1 meter, that means anything bigger than 1 meter, you can see it very clearly in here. If your resolution is 3 meter, so anything bigger than 3 meter, you can understand. The same picture, you cannot understand anything from this one, because here the resolution is 10 meter, and anything bigger than 10 meter you can understand. So from this one you can understand, you can see that each of the things, and you can analyze it later. But from here you can understand there is something, maybe some buildings here, but what type of building, what are the things, how what are the other things associated, you cannot understand. So resolution is an important thing from the satellite analysis. So here come the another thing which is absent in here. Everything is not possible through a very good, what I can say, dependable resolution from the all type of satellites. It might not be possible. If you have a geostationary satellite, then the resolution it would not be a very good one. If it is a polar orbit, then might be a little good one. If you can get the information through remote sensing through aeroplane or maybe some drone, then your resolution will be much more better and you can analyze everything. So depending on the conditions, you can set up your images quality. That means your quality of the picture is good or bad. So from USA, National Imagery Interpretability Rating Scale, they used NIIRS, where they used 1 to 9 different category, where 9 means best and 1 means bad. How they set up that thing? They actually include those things: resolution, sensor types, and everything. They make some rating and then they say this imagery is good or bad. And and when you go for a analysis, you should have a number of the, you should have to understand your how, what is the condition of your images. And then that image you need to, first of all, the orientation should be in there, and the location will be there. You can identify the features, that is a good quality, and also uniquely identified. That means everything should be differently identified from each of them. And also you can get some, when you produce it, you should need the domain of knowledge. That means who produced it. So if you produce it, you should have give your name. So everything in your satellite, and then you can analyze it. So how can we analyze the satellites for meteorological purposes? First of all, we go for an analog system to a digitized system. So to make a digitized one, yeah, what does it mean? So it means a digital images that can be uses by different softwares, and that can give you the idea about the locations, about the latitude and longitude informations, and that can include many information in different layers. Even though they can be also changes, and they can be edited, and they can be used as an analysis. That means your information is stored there and you can take it out, you can segregate it and you can use it. But on the analog system it is not possible. So how can you do that? We can do simple steps as, first of all, fixed a sample distance, the sample reality. That means, from a particular type of analog images, you can take up another one, so that you can set up a target, so that you can say the distance where it is located. And on the basis of that you can fix up some criteria on the basis of their locations. For example, you have a pictures of the, if a school, and then you can get some, you get some information of the location of each four corner. You need the information at least three corners, so four corner information in your hand. You put in the, you scan your images, then put the information in there, so that your location information is in there. So now your picture, analog picture, has been included on information, that is your location. So this is one way how we can take the information in a digital system. And then if you have series of this type of information in there, so you can make some mosaics, so that all the information can be a continuous one. Although this is the images, but you can get this information through making some mosaics. Set a continuous values and map them into a finite number of discrete steps. That means quantization. So this representation from analog to digital, that is called digital conversion. So images that you have taken as an analog system from an analog system, and now you include couple of information in there, so that it can be make a digital format, then it could be a digitized one, and then you can use it for many purposes with different softwares and other things. Image digitization also include couple of other things. That is, one important things is pixel. That means when you have taken your pictures, what would be the condition of your particular sets of data in there. Uh, um, Pixel means from one specific location, what is the amount of the color is located in there. For example, on point, how many colors can be represented in that one point. The more colors is in there, that means the more pixel in there. That means each of the point shows more information in there. So image digitization is a process by which that determines those pixels which is in analog form, that now can be transferred to a digital format so that you can analyze later. Because some information, for example, a billions of green, same color, that can give you a green color to altogether, but maybe there are billions of pixels in there, and that can give you the idea about a particular types of species. Maybe from this one, another sets of green color is different, which can give you the idea about a agricultural crop rather than a big trees. So that is also green, but the differences can be analyzed through your pixels. And how we can use it in our meteorological aspects. So in our meteorological aspects, in different ways we can analyze this system. So from one of the important analysis is NEF analysis. NEF analysis means we can process the satellite data to find out the different aspect of the cloud observation. So how we can do that? We can get the information of the clouds through the images. For example, we can understand the temperature of the clouds, top of the clouds, what is the temperature of that one, what is the temperature of the downward. So temperature information again come from infra thermal sensor. We can get that one, and then we take those information together to understand the temperature of the cloud. Then we can understand the depthness of the cloud to get the information from the visible lights. We can get some infrared lights from the clouds. We can get the movement pattern from the time to time pictures from the satellites. So all the information when come to you through the satellites, and then you analyze it, we called it NEF analysis. And from them we can understood what would be the condition of this one. You can also have some information about the altitude, so that you can find it is a low level clouds or high level clouds, or how depth it is it a horizontal one or is it a vertical one. So everything is now clear in your hand, the handful information in your hand, and you put it into the model so that they can give you some answers. That answer shows you, and then you can forecast it that after 2 hours there will be a big storm coming towards this direction, or there may be a good amount, sufficient amount of rainfall will be happened within couple of hours or the next day. So NEF analysis is one of them, but besides NEF analysis, you can have many more different other type of things. For example, cyclonic event, when it has been happened, so we can understand it 3 days before. How is it possible that it is coming to Bangladesh from 3 days before? It is very, it is dependent on that satellite images. So we know any storm that has been started with on the top of the ocean floor. So now maybe it is 1,000 kilometers away. So there is a low pressure center that has been informed by the images by the satellites from that places. Okay. So we can get that information, and it has been increased day by day. That means time to time it has been increased. We know the wind circulation pattern. We know the movement of that forces. We know the amount of the humidity that has been vertically moved, and we know how quickly it has been increased. So everything information in our hand, and then we put it into our model so that we can understand what would be the probable path of that cyclone. Then we say, well, this will gonna hit in Chittagong, or this will gonna hit in Myanmar, or this will gonna hit in India, or maybe by the side of the Sundarbans. So depending on that analysis, we can answer it. Although it is 2 to 3 days before, so everything is dependent on your observation, and that observation is possible through satellites very well. And then these satellites depends on the observation of the rays or radiation that is coming from the different objects, and that would be analyzed through different models, and you can get the answers. So I think this is all about this satellite picture analysis for now, I guess. So if you have any question, you can ask me regarding today's lecture. Can you hear me?
Yes, sir.
Okay. So if you have any question, you can ask me, or maybe if you don't have any question, then we can close it up. In the next class, we will start a new chapter, and hopefully we'll come back in the next Monday, same time.
Okay, sir.
Okay.
স্যার একটা রিকোয়েস্ট ছিল।
Yes, please.
স্যার 12 and 13 যে লেকচার ছিল স্যার, ওটা সম্ভবত আপলোড করা হয়নি স্যার। সম্ভবত 11 লেকচারটাই 2 বার রিপিট হয়েছে স্যার। এটা কি একটু দেখা যাবে স্যার রেকর্ড ক্লাসটা? স্যার
Sorry.
12 and 13 স্যার। স্যার 12 and 13 লেকচারটা স্যার দেওয়া হয়নি স্যার। মানে ভুলে 11 নম্বরটা 2 বার চলে এসেছে স্যার।
Acha, acha. So I'll see that.
স্যার, স্যার থ্যাংক ইউ স্যার। স্যার
Okay.
আপনার স্যার।
So thank you all for joining me, and hopefully we'll come back in the next week. Thank you all.
Assalamu alaikum, sir.
Walaikum salam.